Good morning, friends. Today we are going to be looking at modeling with exponential functions. So far this unit, we have dealt with what are exponential functions, radicals and rational exponents, looking at exponential functions, and then also exponential growth and decay. Today we are looking at modeling. Our learning target is to model real life problems. And then you can see our success criteria will include growth and decay functions, and also compound interest. All right, so writing exponential functions, we have the exponential function formula, y equals ab raised to the x power. The y values change by a factor of b as x increases by 1. You can use this fact to write an exponential function when you know the y-intercept. Y-intercept is noted as a. Here we go. The graph represents a bacterial population Y after X days. Find the population after 12 hours and 5 days. So we have two answers that we are looking for. We are looking for after 12 hours, and we are looking for after 5 days. So we can see from the graph that we do have an exponential function. This is not linear. We have a slower build, and then at some turning point, it becomes an exponential growth. We know it's growth because it is going in a positive direction. One way to find it is to write and evaluate the function that is represented by the graph. So here we have plotted a few points. Here is our y-intercept. Whenever x is 0, the y value there is the y-intercept. And then we can look at the growth factor. The y-intercept is 3, as we said, and as x increases by 1, y is multiplied by 4. Here x is increasing by 1, and y is multiplying by 4. So it can be written as y equals 3, that's the y-intercept, times 4, that's the multiple, raised to the x power. So now let's find it after 12 hours and after 5 days. So that looks like this. Here we have our function y equals 3 times 4 raised to the x. And we're writing that in days. 12 hours is how much of a day? Well, a day is 24 hours. So 12 over 24 is 1/2. So 3 times 4 raised to the 1/2 power. So we have 3 times 2, because of course we have to do our exponents first. Exponents come before multiplication. 4 raised to the 1/2 power is 2, and then 3 times 2 is 6. So there will be 6 in the population after 12 hours. Now let's look at that 5 days. We still have y equals 3 times 4 raised to the x power, but this time we're already in days. So it is 3 times 4 to the 5th power. Now remember, you do have access to your calculators. You can go 4 to the 5th power is 1024 multiplied by 3, and we get 3072. You can see here how this exponential function really changes. 6 bacteria after 12 hours, 3072 bacteria after 5 days. Sometimes you're not going to have a graph. Now, granted, for most tests, you'll have graph paper accessible, but not terribly easily graphed. What you can note is that your x values are increasing by 1 and your y values are decreasing. So this would be decay if it's exponential. Notice that we have 18 less, and then this is not 18 less. So I have to figure out what the difference is, y2 over y1, and I get that it is an exponential decay. And I can look at this as the y-intercept is 180, and it is decreasing or increasing as a multiple of 0.9, so less than 1, which is why we have a decay. It is greater than 0, but less than 1, so that tells us it is an exponential decay. So now let's put it into our formula to predict. 180 is our y-intercept. That goes in the A spot. 9/10 is our exponential portion, so that goes in the B spot, and we're raising it to the x power. Our x power for this is going to be the 3.5 minutes after it's poured. So 180 times 0.9 raised to 3.5. Of course, you're going to do the exponent first as our order of operations, and then multiply by 180, and we get about 124 and 5/10. So after 3.5 minutes, the temperature is about 124 and 5/10 Fahrenheit. Okay, so now let's look at compound interest. Compound interest is the interest earned on the principal. That's the money you start with. And on previously earned interest. So this is different from simple interest. Simple interest is only interest on the principal. Compound, you're going to have interest on the principal and previously earned interest. That's why this is different. It looks similar, but it is different. Notice that the Y is the account earnings of the compound interest. P is still our principal. R is still our rate in decimal form. Here's where it changes. N is the number of times the interest is compounded per year, and it's in two different places. It's here underneath the annual interest rate to find how much of interest is per compounded section of the year. And then it's also up here next to T, which is time in years. So let's take a look at what that is. You deposit $100 in an investment account earning 6% annual interested compounded monthly. So think about how many times that's going to be compounded monthly. Right, so 12 times in a year because there are 12 months in a year. So we have M of T. M is that balance. They gave you that, T after years. Okay, and here's our compound interest formula. And we want to know the compounded interest after 5 years. So first off, we have our $100 principal, 1 plus, that doesn't change. Our rate, 6%, is 0.06 in decimal form, compounded 12 times in the year because it's compounded monthly. And then we have 12 because that's how many times it's compounded, T. So here is our initial equation. And now let's plug in 5 years for T. So when T is 5, M of 5, notice that's that T. And every time I see a T, I'm going to put a 5 because that's what I'm solving for. 100 times, and I went ahead and simplified inside my parentheses. Order of operations says I can do that. 12 times 5 is 60. So 1 and 5 thousandths raised to the 60th power, then multiplied by 100 would be about 134 and 89 hundredths. Not a lot of growth in that balance. If I left it in longer, I would definitely have more growth. All right. Oops, that one again. Sorry about that. Just in case you needed to see it again. So here we have one more practice. We have $800 in our account as our principal. We have 2% interest compounded monthly. And we want to find the balance in Y dollars of savings. What can you determine about the account? Well, you can determine that it was started with $800. You can determine that the rate is 2% and that it is compounded monthly. That's about all you can determine because you don't have time and you don't have the final outcome. But that's a lot to know. I hope this has really helped. If you have any questions, be sure to ask your teacher, and we'll continue talking about this in class.